All right, welcome, ladies and gentlemen. I think I'm going live here. What I'm going to do in this live stream is go ahead and go through my quiz that I gave to my students on rational functions for pre-calculus. So I am still trying to test out these new features that are coming down our pipeline here. And actually, you know what? I'll check out my internet connection. Hopefully this stays strong. Stay strong for us. But what I'm going to do is we want to go through this. I do have this on the not taking suggestions or questions in this one just because I want to make sure I go through this. I do have it on the member only kind of stream. So therefore, obviously anybody that's members that adds in, I'll maybe I'll be able to do a Q&A kind of at the end. But otherwise, I just want to make sure I can kind of go through this content here. What we're going to cover is dividing rational expressions, simplifying complex fractions, identifying asymptotes, holes, and intercepts, solving rational equation, and then we'll kind of do the same thing here with some multiple choice questions as well. So kind of get a taste of some free response as well as multiple choice. So again, this was a quiz that I recently just gave to my students this week, and so I just want to kind of run through the answers. So therefore, they have a kind of cheat sheet, and you guys can also make sure that you have some have a video to kind of follow along with. So let's go ahead and get started. From in there. And again, if you do have some questions, though, feel free to add them down into the regular chat on the replay, and I'll try to respond to you guys as best I can as far as any clarifications that you'd like for any of the problems. So I did already grade all of my students' quizzes for there, so I do want to kind of come through. I also want to go over these with also some feedback as far as what I saw. So the main thing that I wanted to look from students in here was the idea of them factoring. I wanted to make sure that students could show me that they knew how to factor. And I gave them 4 opportunities to be able to factor. So the first one was, again, a polynomial to the higher power. So I wanted them to factor it kind of like it was a quadratic trinomial. But obviously, this multiplies to give you a quadratic, x squared, and we want it to be x to the 4th. So I'm going to raise that to x squared in both terms. And if you check that answer, you can see that that would multiply here to give us our numerator. Down below here in the denominator, I can factor out a x. By factoring out an x, I'm left with a 2x minus 1. Now, the next thing I wanted to make sure that I could see our students were showing me is that they understood the division of a fraction is the same thing as multiplying by its reciprocal. So in addition to students factoring, I wanted them to be able to show me that they could multiply this. Now I have a little room over here, and some of these require a little bit of steps. So what I'm going to do is, this was a polynomial with 4 terms. So therefore, I was going to factor this one by grouping. And when I factor by grouping here, I can factor out an x squared. That's going to leave me with an x plus 1. Here I can factor out a negative 3. And actually just want to factor out a positive 3. If I just factor out a positive 3, yeah, that's going to leave me with a x plus 1. Okay, there you go. And then in the denominator, that is the factoring by grouping, and then I'll kind of rewrite this one more time. In the denominator here, I know that this is going to, a quadratic trinomial is going to produce a product of 2 binomials. So I know I'm going to have a 2x here and an x. And then really, I only have one option here. It's either 1 and positive 1 or negative 1 and negative 1 that are going to multiply to give me positive 1. However, since my middle term is negative, I know that both of these numbers have to be negative, right? Because again, remember, the product of my inner and my outer is going to produce that middle term. And therefore, if they're both positive ones, then that middle term would be positive. So since my middle term is negative, they're both going to need to be negative. So let's go ahead and rewrite this now. Let's factor out the x plus 1. So I'm just kind of doing the factoring form of this. And again, guys, I'm also, doing this a little bit faster than I would if I was teaching this for the first time. So I do apologize for those of you that are kind of, using this as maybe a learning tool. I'm going to be skipping some steps or not explaining everything for there, because also I want to, make sure that my students are not getting bogged down by a lot of the inner details that we've already talked about over and over in this class. But either way, this was really the main first point that I was looking for students to be able to get to, is multiplying by the reciprocal and then factoring everything as much as you could. So you can see I used an array of factoring techniques here for students to be able to, to factor, or to show that they knew how to factor. And now, since every single one of my quantities is separated by multiplication, I can now just go ahead and apply the division property to divide terms out. So remember, the division property is when you have a term divided by itself, any times across a multiplication, separated by multiplication, you can just divide to 0. Did I forget to flip that? I did. I'm such an idiot. So you notice how I just kept the numerator there and the denominator here? So you can't change that to division. So I'm going to, here, I know what I'm going to do. I'm just going to rewrite it. I don't want blue. I can't believe I read it. This is what happens when you talk and do math at the same time. So I know my numerator is going to be 2x minus 1 times x minus 1. And then over here is going to be an x squared minus 3 times an x plus 1. All right, so what I'm going to do is I'm just going to do a little bit of magic here just to save myself some time. And then I'm just going to move this over. There you go. And then if somebody doesn't watch the video and just looks at the answer key, they'll have no idea that I made that mistake. All right, so now let's go back into it. I'm just going to use blue just so you guys can differentiate, see what's being divided out. So in this case, you can see that the x squared minus 3 and the x squared minus 3, they divide out, right? They're separated by, quantities are separated by multiplication, and one's in the numerator, one's in the denominator. The 2x minus 1's and the 2x minus 1. But what we notice here is x squared minus 1 can actually be factored one more time. 2x minus 1 times x plus 1. Therefore, that allows the x plus 1's to now divide out. And now I'm just left with a x minus 1 times an x minus 1, and in the denominator, I just have an x. So then we can simplify that to x minus 1 quantity squared over x. And that was the answer choice that I was looking for on the students. All right, let's go ahead and move on to the next one, which is a complex fraction. So when we worked on complex fractions, we kind of I taught them a little bit differently than I taught the operations, because rather than applying the operations in the numerator and the denominator, I told students, let's just get rid of the fractions. So the easiest and best way to get rid of the fractions is to multiply by the LCD. So we're going to multiply, actually, you know what? I'm going to show my work on this one a little bit more. So the first thing we did is I said, well, what is the common denominator? So we look at all the denominators, 1, 2, 3, 4, and you can see that the common denominator is, the least common denominator is a denominator, we should really call it the least common multiple, is the expression in this case that each and every one of my denominators evenly divides into. Now, if they don't have any factors in common, which in this case they don't, the easiest way to find a common multiple or denominator is just to multiply your denominators together. And in this case, since they don't have any factors in common, I'm just going to use the product. So again, to represent this, a lot of times I put them outside parentheses and I multiply, and I'll show that for another problem. But for this one, you got to make sure you multiply every single fraction or every single fraction by this common denominator. Because the whole point of multiplying by the common denominator is to get rid of our fractions. Okay, and so what you can see is this is in the numerator. Now I have my denominator divides out, which is just going to leave me with an x squared. Here, then that's going to leave me with a negative, here the x's divide out. So that's going to leave me with a negative 1 times x minus 1. Divided by, here the x minus 1's divide out. So now again, I'm left with another x squared. And here the x's divide out, leave me with a positive 3 times x minus 1. So a couple mistakes students made here is the one, they saw the x squared in the numerator denominator and they wanted to divide them out like we did up here. But again, notice how these quantities are not separated by multiplication, right? So we can't do that. So therefore, we need to, you could simplify and see if they're factorable, then you could do something like that. But if they're just terms separated by addition and subtraction, we can't just divide them out. The other mistake students made was go ahead and not distributing correctly. So they made some mistakes. They forgot to distribute the negative to both terms and the positive 3 to both terms. That's a 3x minus 3. Okay, so that was our go ahead and our final answer there. Just make sure again that LCD and then just distribute it. All right, on to question number 3. Identify the asymptotes, the holes, and the x and the y intercepts. Oh crap, I forgot. I changed this problem and I forgot to write it down and I didn't do my review. Let's see if I remember what the problem was. I forgot I changed this and I didn't change the quiz. Crap. All right, so I had 4x squared minus 8x. It was 2. I think it was -2. I'm going off of, no, it needed to be -8. Crap. Hold on a second. I changed the problem for my students. So actually, let me just use black here. And then, you know what, I had the key. And I was like, oh, I don't need the key. I've already graded somebody. I'll remember all my answers or all the questions. Of course. All right, so I think I remember the 4. I know the denominator was 4x minus 4. Okay, so then this was 4x squared. And then I know that one would be a 2. Yeah, so that would be a minus. Was that a 2? No, minus 4. I think that was a minus of 4x. No, plus 4x. Well, guess what I'll do? I'll simplify it, and if it's not right, I'll go ahead and fix it. And then I think that was minus 8. Yeah, but those were the same. Dang it, I can't believe I forgot that answer. And now I'm confusing this with all these other problems that I've been doing. Maybe that is. All right, let's go ahead and simplify it. So anyways, I think this black, I changed this problem just because I didn't really like it. So on the quiz, I believe this was it. And one of the main things I told students was just like we did in the first problem, like simplify, right? It's, you know, just simplify the expression. So in this case, I'm going to factor out a 4, and I'll remember if it's correct by factoring out the 4. By factoring out the 4, I get an x squared plus x minus 2 all over a 4 times x minus 1. Now, I can factor this one more time. And I don't know why I'm doing this. Let me do this in blue so therefore people can understand the difference. Sorry, guys. You got me. I'll be right back. So you want to know what happens when it's the end of the week and you try to force a live stream to make sure you have the answers before the weekend for your students? You end up making mistakes and forgetting your charger. So sorry about that. But let's go ahead and move on with this. Let's divide this answer. Jeez, man. I got to go too. I'm trying to fit things in between meetings just because I want to get this live stream in. All right. So we go ahead and factor out the 4 in the numerator. And that gives me an x squared plus x minus 2. And then down below, I factor out a 4, and that leaves me with an x minus 1. Okay, so a couple things is when we simplify this, we notice the 4's divide out, right? But remember, 4's are scalars, right? That's just a scalar there, so that's not really impacting anything as far as like asymptotes, holes, or y-intercepts. But what we notice is I can factor out this numerator here one more time. So that would be an x plus 2 times an x minus 1 divided by an x minus 1. So something very interesting happens. Now I've rewritten it as a product. You couldn't divide anything else before, but now that everything is separated by multiplication, now we can go ahead and factor divide terms out. And what we notice is the x minus 1's divide out, obviously the 4's divide out, so therefore that now leaves us with an equation of just x plus 2. So that's exactly what the equation is. It's just x plus 2. It's a line, right? But we got to understand, like, you mean this equation creates a line? And the answer is yes, that equation does create a line. Kind of weird. So then what do we talk about the discontinuities? Like, what about the denominator being 0? Well, that just means there's a hole at x equals 1. Because 1 is a discontinuity, right? 1 makes the denominator equal to 0. And since x minus 1 got divided out, we know that's a removable discontinuity, so therefore that is a hole. So as far as asymptotes go, there are none. There's not a horizontal asymptote, there's not a vertical asymptote, and there's not a slant or an oblique asymptote. Now again, let's kind of go through this because it gets a little confusing when we look at this. So First of all, vertical asymptote. The reason why there's not a vertical asymptote is because the discontinuity is removable. Holes are removable discontinuities where vertical asymptotes are non-removable. So since the denominator got divided out, it is a hole, not an asymptote. Let's do horizontal asymptotes. Whenever the degree in the denominator is smaller than the degree in the numerator, there's no horizontal asymptote. That is from the horizontal asymptote test. So then a lot of people assume then there has to be a slant asymptote. Well, yeah, there's a slant asymptote if the denominator doesn't get divided out. And you can see that this denominator evenly divides into the numerator. So therefore, it doesn't create a slant asymptote. It's actually just a hole. So, because when you graph x plus 2, I think this was minus 2. I think I changed that to plus 1. So either way, the answers are going to be very similar. Yeah, because I think that was at minus 2, but whatever. So when you guys go ahead and... Jeez, can't even draw a line. That was it. I did change that. I think it was to be plus 1, and then that was to be minus 1. Okay, well, yeah, because the hole was at x equals 1. Right? Hole's at 1. Yeah. So anyways, this is what the graph looks like. And then you can see that there is a hole. There'd be a hole right here at 1. Right? So that's basically what that graph produces. All right? So there's no asymptotes. I'm not going to write it in there because it just said identify them. And since there's none of them, I'm just not going to identify them. As far as my x-intercepts go, x-intercept, remember, is when y was equal to 0, or what we learned is when basically the numerator is equal to 0. Well, you could plug y equals 0, or this numerator equals 0. That's kind of a lot. Then you had to do the factoring. We could set this one. Well, in reality, guys, this all gets simplified. Like this equation got simplified to y equals x plus 2. So why don't you just plug 0 in for y here? And you can see the math is rather easy. X equals -2, which makes sense, right? Looks like it'd be right at -2. And as far as the y-intercept goes, that is when x is equal to 0, right? Which we said basically was constant over constant. And you can see -8 over -4 produces 2. Or if you really just want to plug 0 in for x, you can see you're going to get y equals 2 as well. So there's kind of two different ways you could have gone about identifying those intercepts. I'm just going to write no asymptotes here just in case. So no horizontal asymptote, vertical asymptote, or slant asymptote. All right, the next one is solve the rational equation. So just like there's too many fractions when I was solving, we can't solve for x when it's in the denominator. We have to get the x off the denominator. And to do that, we want to eliminate these denominators. So just like we wanted these denominators to divide into our LCD, we're going to need these denominators to divide into our LCD of this problem. Now, instead of multiplying everything to produce an equivalent fraction, now we're going to want to multiply the LCD to produce an equivalent equation, right? Whatever you do on one side, right, you have to do to the other side. You have to multiply everything. You got to make sure you distribute that to produce that equivalent equation. You just can't multiply one thing in an equation because that's going to change the value of the equation. So again, now in this case, we don't want to go as easy as just, and here's like a common mistake students make. They just see the denominators and they just multiply them, right? Because in this example, that's what happened. But if you did that here, well, you're going to have a really big LCD. X times x squared plus x times x plus 1. Like that's kind of huge. So what I notice is if I factor this gives me actually the product already of my other two denominators. So not only is this have the product of these two, this one, so now we can say that the LCD, what they have in common is these two have x in common, these two have x plus 1 in common as far as factors in common. So therefore the LCD here is just going to be x times, I don't know why I wrote a plus, x times x plus 1. So in this case, rather than multiplying every single term or showing that, I'm just going to put it on the outside and say I'm using distributive property. So therefore I'm going to multiply this times each and every one of these terms. So hopefully you can follow me now as we go ahead and do this. So if I was to multiply this quantity times 2 over x, the x's would divide out, and I would just be left with 2 times x plus 1. If I was to multiply this quantity times x plus 1, my denominator, the x plus 1s, would divide out, and I'd be left with a negative 1 equals, and then here the quantity x plus 1s would divide out, leave me with an x squared. now I just make sure I apply my distributive property. And therefore I get 2x plus 1 equals x squared. So now we're at a point where we see we have a quadratic. And I saw a lot of students making a lot of, very common mistakes here. But remember, guys, this is a quadratic equation. So we can, when we want to solve a quadratic equation, and we have two variables, like we have a linear x and we have a quadratic x. So we can't use inverse operations like we did with when there's only one variable or when it was like a linear equation. We can't combine like terms, right? So therefore, to isolate the x, we either need to use the zero product property via factoring, quadratic formula, or completing the square. So to do that, first of all, we got to have it set equal to 0 for any one of those options. So I'm going to subtract the 2x and subtract the 1. So I have 0 equals x squared minus 2x minus 1. And now I want to see if it's factorable. What two numbers multiply to give me negative 1? 1 and negative 1. And they don't add to negative 2. So therefore, it's not factorable. Therefore, I have to go back and use the lovely quadratic formula, opposite of b plus or minus square root b squared minus 4 times a times c, all divided by 2a. So now, remember that's from the standard form. Oh, what happened? Okay. So you're, I knew that was going to happen. Video output low. Fine. See what happens here. Still going, still going, still going. Well, I'm still just here recording. Hopefully this brings up the stream health. I apologize if you guys have had any delays on that. But remember, the quadratic formula here comes from the a x squared plus bx plus c version. Let me try something here. Yeah, it looks like there's just a little delay. Sorry, guys. Sometimes just the internet didn't know if it was me on my side or not. But yeah, all right. Looks like everything good. Hopefully the output will just be a little bit better. So therefore, in this we're going to have opposite of b, which is going to be 2, plus or minus the square root of negative 2 squared, which is going to be 4, minus 4 times a, which is 1, times c, which is negative 1. And that's all below 2 times a, which is 1. Okay, so as you can see here, that's going to be 2 plus or minus. And then what we have is, negative 4 times negative 1 is a positive 4. So it's really 4 plus 4, which is just 8 divided by 2. Now, remember the square root of 8, it can be broken down into 2 square root of 2, right? So therefore, x we have 2 plus or minus 2 square root of 2 over 2. Distribute the 2 in there. You're going to have 1 plus or minus the square root of 2. Now, again, we could go back and check our answers, obviously, but we know that 1 plus or minus square root of 2 is not going to be extraneous, right? We want to make sure that our solutions satisfy the original equation. And in this case, you can see that 1 plus or minus square root of 2 is not going to make any of my denominators 0. So therefore, we can say that, they are not going to be extraneous. So those were the free response questions that I had my students go ahead and solve. And then I gave them just some multiple choice ones. So on the multiple choice, here's just a very basic simplifying problem. So the first thing I would probably do here. Now, again, when I'm doing the simplifying, I'm just not going to work through everything. I'm just going to do the basics here. So therefore, I can determine what the answer would be. And you can see that the x minus 1s leave out. So that'd leave me with a 1 over w plus 1. And that'd be a negative 1, I'm sorry. And you could throw that negative in front. So therefore, you can see the answer is C. So I'm just kind of doing, here, I don't want to make anybody confused. All right, and so that negative can be put in front, but again, we have to have the denominator w plus 1. All right, solve the equation. Here, let's see, I noticed that my LCD, this can be factored to x minus 3 times x plus 3. So therefore, this is already x minus 3, so therefore I'm going to multiply x minus 3 times x plus 3. So I'm going to multiply this, multiply everything times the LCD. So x minus 3 times x plus 3. So when I multiply this times that, everything divides out, obviously. That's just going to leave me with a 6. Minus, the x minus 3s are going to divide out. So that's going to, oh, what am I doing? Equals. That's going to be a minus a 1 times x minus 3, so that'd be x plus 3, times an x plus 3. And then equals x minus 3 times x plus 3 times 1 is going to be x squared, minus 9. So again, we're going to have a quadratic here that we're going to need to solve. So that minus x minus 3 equals x squared minus 9. Remember, you have your quadratic, set it equal to 0 here. X squared plus x, let's see, that becomes 3, so that becomes a minus 12. So now we want to see if it's factorable, or do we got to use the quadratic formula? Thankfully, we see that this is going to be factorable. So it'd be x minus 4. No. Crap, what did I do wrong? That's a negative x. X plus 3. And I thought that I had that right. Oh, that's supposed to be positive. You're right. X minus 3. Who am I saying you're right? I'm talking to myself. X minus 3. There you go. So therefore, we can see that x equals negative 4 and x equals positive 3. So we look over the answer D, but we remember when we're solving equations, that we got to make sure that our solutions satisfy the original equation. Well, when I plug 3 into the original equation, that makes that 0. So therefore, this is extraneous. So therefore, that's not the right answer, but negative 4 is the only solution. For question number 7, we just need to use the horizontal line test to determine the horizontal asymptote of the function. Well, again, just recommending when we're doing the horizontal line test, we're just understanding that when the degree in the denominator is less than the degree in the numerator, there is no horizontal asymptote. There could be a slant, or it could be holes, or they could be both. But either way, there's no horizontal asymptote. The next one is, what are the x and the y intercepts? Remember, to find the x intercepts, you're basically just setting the numerator equal to 0. And so therefore, let's say 0 equals x squared minus x minus 12. Factor that. This one would be x minus 4 times x plus 3. So therefore, we have 4 comma 0 and negative 3 comma 0. So either going to be A or C. And then for the y-intercept, if you remember our kind of trick here, we can just take constant over constant. So y equals negative 12 over 6, which equals a negative 2. So therefore, that's going to give us 0 comma negative 2. So our answer choice is A. All right, and last but not least, guys, is another simplifying complex fraction. So again, I'm going to identify the LCD, which in this case is just going to be x minus 1, x plus 5. Okay, I'm going to multiply every single term times that. And by doing that, the x minus 1s here divide out. So that's going to leave me with an x times x plus 5. Here, the x plus 5s divide out, leave me with a positive 3 times x minus 1. All over, here, the x plus 5 divide out. X plus 5, x plus 6, leave me with a 5 times x minus 1. And then minus x minus 1s divide out, leave me with a x times x minus 1. All right, so now it really just kind of comes down to, oh, and I changed these answers too. God, I can't believe I forgot to change the quiz. Sorry, guys, this is like in a rush. These were supposed to be negative, and I can't remember what other change I had. I think this is supposed to be negative as well. Yeah. Yeah, that was supposed to be a negative 3. I like messed up all of these. Sorry about that. So therefore, now let's just go ahead and distribute and then combine like terms. So in this case, I have x squared plus 5x plus 3x minus 3. So the one thing is I noticed that my constant is negative 3. So it can't be that one and it can't be that one, right? So it has to either be B or D. So then I'm just going to look in for the denominator. Which one is going to give me? Is it going to give me this trinomial or this binomial? So when I distribute here, I get 5x minus 5 minus x squared plus x. That was supposed to be an x minus x plus 5. Dang it. So I wrote that down wrong. That's actually supposed to be a 5x. And you could simplify them to get your answer, but you didn't even need to simplify it from there. You can see that this simplified is going to give you answer D. So there you go, ladies and gentlemen. That is the quiz that I covered for my students on rational functions. Again, covering complex fractions, x and y intercepts, asymptotes, solving, simplifying, and then we work through the free response. So hopefully that was helpful. If you're covering any of this in college algebra, trig, or anything like that. And there you go. That's the answers. Look forward to seeing you guys on the next video. Cheers.